2005 Toyota Caldina. This has the dreaded 1AZ FSE engine that Kenyan mechanics really don't know how they work. That's the D4 engine. So the complaint with this is it has got two error codes. P0191, that is the initial one, and the customer says that he stalls on the highway or he loses power. Usually when he loses power, it's followed by a stall. And interesting stuff happened after that. So he went to Auto Express. Auto Express did a preliminary scan for him and showed the P0191. So this is after he started stalling intermittently on the highway. And that is fuel pressure sensor range performance. He went to his mechanic, and his mechanic replaced the fuel pressure sensor, which is at the back of the fuel rail, and that didn't solve the problem. And then the swaptronics and games began. So right here we can see that there are two fuel pressure sensors, so I'm guessing it has been replaced at least twice. So one is the original one, one was replaced. That didn't fix it. Then they replaced the high pressure pump, but this one I'm told was replaced because they tampered with this, which is the fuel pressure regulator, and it could never seal after that. It just kept leaking, so they changed that with a used pump. The other thing I'm told has been changed is the pump in the tank, and the 191 didn't go away, but in the midst of doing all this and replacing this, another code was introduced, and that is P0191, that's system 2 lean. So before we do a diagnosis, I just want to show you something. This is why I tell clients, be very careful who you take your vehicle to. I diagnosed this car about 2 years ago, and this car was in such immaculate condition. Since then, the engine has been changed, and this is the look of it right now. This is just horrible. Harness destroyed. See that? You got the harnesses out here. So that's the used part that they put in. It's a bit rusted. More harness damage down here. We got hoses here that don't look like in very good condition. Yeah, so this is what happens when you do too much swaptronics and when you use local mechanics who are in a hurry. Be careful who you take your car to. So this car did not look like this, and now this is what you have. It's unfortunate, but that's how it goes. So I want to start this car, and I want to get the scanner on it. Let's scan the codes that it has, and we begin from there. So this car has a problem. It seems to be killing my scanner every time I start it. Sounds like the battery is low. So let that boot. We are at an impressive 432,992 kilometers. Car is running really rough, not very well. So let's read our codes. So we've got a current, P0171, system 2 lean, P0191, fuel rail sensor circuit range performance. So this was the original code that had been there, and this was what was happening when his car was stalling. And this one, I'm made to understand, was introduced when they began changing out his sensors. So let's see some live data here. So right now we're in closed loop, and here our fuel trims are really high. So we have a long term of 27.3%, short term climbing up 14, 17, 93. So that's maxed out right now, 1949. So this is max fuel trim, so we are that lean. Let's take a look at some more. And look at this, our oxygen sensors are completely zeroed out. It's so interesting. Is this a dead sensor, or are we that lean that we are that low? Let's see. Let's take a look at our fuel pressures. Right now fuel pressure is 8 MPa, and that's actually what it's supposed to be at idle. So that tells me the low pump and the high pump are working currently. Okay, interesting. So right now I see why the 171 is setting. I don't see why the 191 is setting, and in my mind I can't see how the two are related. So here's what I want to do. Let me take a custom list, and we'll take our long-term, short-term map. Give me the front O2. And fuel pressure. Oh, and fuel status. So let me just go back out here. So I've just added a fuel system here, and I wanted to see whether we're in closed or open loop. Let me just Alright, that's a better look. So I'm interested to know, is this a true lean condition because we are that lean, or is our oxygen sensor dead? It's very rare to see an oxygen sensor flat at 0. So it either means we have flooded this engine with so much oxygen that the computer is unable to keep up, or it's dead. So I want to take a fuel spray and spray in the intake and see if we are going to change our oxygen sensor reading. So let me do that right now. I'm just going to use starting fluid, and I need to spray in the intake airbox there, but I'm hearing a leak. There's a vacuum leak on this engine, and it's pretty pronounced. This engine is hissing. So what I want to do is we're going to add some starting fluid here. We're going to spray around here, and we're going to watch our oxygen sensor and our correction. If we see that rising, then we know that we have a vacuum leak and we just need to identify it. So there we go. You can hear something. If you look here, look at our oxygen sensor. We've gone full rich, and right now I'm spraying in this area here. We're going to open loop, but our oxygen sensor has gone rich. So that tells me we have a vacuum leak in this engine. So next step is, let me hook up my smoke machine, and then we smoke this intake, find out where our leak is. But that explains our P0191 system 2 lean fault, vacuum leak. Does not explain the 191 yet, but let's smoke the intake. We got one leak here. We have another leak at the back. So here's one leak. We got another leak back here. And that just looks like that's not tight, so just tighten this. Oh yeah, that wasn't tight. You still have another leak back there. That is coming from the evap hose, and that's a very big leak. So let me block these two leaks for now, because I can see the evap hose is leaking. This is leaking. Let me block those two, and then we focus on the intake. I think we have another leak on the intake. So I've just covered that one with a cone, and I've covered my evap with an old glove. It's the pipe here that's broken at the tip, and that is the pipe that is just in bad shape. So we need one of these, and we need an evap pipe, which is this one here. But I don't think that's the only one, so let's start up our smoke machine again. There we're going. It's too much of a leak over there, so what I'm going to do is to just block this opening here with my hand. It's my finger there. And let's scope that intake. I think we have another leak on the intake. Yeah, that's it. There we go. Let me zoom you in there. So that leak is coming from the intake. Now the sun is making it a bit hard to see. And we have a missing bolt on the intake as well, over there. There is a smoke from the intake, now you can see it clearly. And also on the side over there we have smoke. So this intake needs to be resealed, and the two pipes. So that'll take care of our 171. That doesn't tell us anything about the 191. So I don't think those two are related, because you say the 191 was there and this was all induced when the fuel pressure sensor was being changed out. So let me think of what to do with the 191. After thinking a bit about this, here's a strategy that I want to employ. I do not believe that the P0171 is related to the P0191, and here's why. He had the 191 problem prior to the 171, and the 171 appears to have been induced when they were installing the fuel pressure sensor, because they had to remove the intake. So all those torn hoses and the leaky gaskets is because of that work. This car has an inherent 191 problem, and that's what I want to solve. Now, I do not have the original manual for the Caldina. The one I had in my repository was corrupted. I could not open it, and I did not have a backup, unfortunately. So I need to purchase a new one. For now, I'm going to use motordata.net to get the wiring diagram just for the engine, because I will need the engine wiring diagram to proceed. I want first to isolate, is our pressure drop high side or low side? So here's what we're going to do. Here's the engine computer. It's just behind the glove box. I've removed the glove box, and I'm going to pay for a 1-week subscription to motordata.net, and that'll help me at least get the wiring diagram and the pinouts for this. So I'm going to pull on channel A the high pressure pump. That will allow me to see the fuel rail sensor. That will allow me to see the high pressure line and see when we will lose that pressure. Then the second thing I want to do is to tee in a low pressure sensor, because this car does not have a low pressure sensor. So we're going to come here on this location. This is my low pressure line. I don't have the adapter for this, but I do have, if we follow this down here, I do have the adapter for this. So let me get my torch, put it in there. And we will tee in a low pressure sensor here, and I'm going to view that on channel 2. Then the third thing I want to do is to get all my injectors from here. This is my injector driver. I'm going to take the injector current by looping all the injector current lines here, and then the last thing I want to see if I can do is to get all my coils on a 4th channel. So if we have a line that comes here so that I can view all the coils, I will get a current ramp from all that. That will allow me to see, one, are we losing fuel pressure? And if we are, is the fuel pressure dropping on the high side or is it dropping on the low side? Then it will also help me see if we're not losing fuel pressure, what are we losing? Are we losing injection or are we losing ignition? So let's set up those 4 channels and then we will go on a test drive. So let me go to motordata.net and see if we can get our wiring diagrams. Here we are in Motordata. Now, this is the best resource if you don't have any OEM wiring diagrams. This is the best resource to get wiring diagrams for JDM cars. And that's why we are using it, because Caldina is an exclusive JDM vehicle. So let's look for the Caldina. Ours is ZT24 and it is after 2005. Now, is this 2-wheel drive or 4-wheel drive? Let me just quickly check the drivetrain. Okay, this is a 2-wheel drive. It does not have a drive shaft that goes to the back. So we have a 2-wheel drive, and we come to a wiring diagram. Okay. So that's our engine control unit. And let's look for our fuel pressure sensor. It has got 3 lines. It's one of these. Brake booster sensor, map, fuel pressure sensor. So that's where it is. So it is on pin 23A. And if I want to see where it is, I go to the pin data, and there it is on the engine computer. So I'm going to pick this line. Let me see if I can get all my coils in one shot. So the injectors, I will go to the injector driver and I'm going to pick, I can see this is a shared line, so this is a power feed. So I'm going to pick 5A, which is going to be a white, and this other one here, 6A, which is a blue. So I'm going to tie these two together, and that will give me my injector control, sorry, my injector current, and I will see all 4 injectors. And then for the coils, these are just control lines for the coils. Let me see if I can get a different view of that. So I go home, engine electrical system, ignition system, this one. So that's the engine control unit, and there is a black red wire that comes out that feeds all those coils, but there's also a ground point here on EP8, white and black. So let me see where that is. Very convenient. So it's right at the top of the engine. So I'm going to put my clamp here and get the ground for the coils, and I'll be able to see the current ramp for all the coils. And then I'll set up my fuel pressure sensor for the low fuel side. So let me set all that up and I'll show you briefly, and then we'll go on a test drive. Here are our connections. Channel 1, we have our low pressure pump PSI output. So I've just teed in a gauge right there. That's my T down there, and it's just coming to my gauge, and the gauge is electronic, and that's connected to my box here, and that's what's connected to the picoscope. That's a power supply for the sensor. So channel 1 low pressure sensor on the low side fuel rail. Channel 2 on the ECU inside is the high pressure fuel sensor, which we cannot get to because it's buried under the rail, so we're getting to it from the ECU. I'll show you that when I go in the car. Channel 3 is the injector current, so power supply from injector number 1 and 3, power supply from injectors 2 and 4, picking up from this on the current clamp. And channel 4 is my ground termination for the coils being taken by this current clamp. Now, I do not like that wire. Look closely. This wire doesn't seem like it's very, very secure over there. I'm not going to touch it. Let's go over to the car. And there's our Pico setup. And channel 2, that's the fuel pressure sensor output. Everything on the scope. I'm going to start the scope. The scope is running. Put the key on. And let's start the car. Very interesting. The first thing I see is my low pump, which is a blue channel, is over pulsating. I don't like what it's doing. Let me pause that and zoom in here. So there's quite a big pulsation over there. Let me close this. I don't think we even have to go on a test drive. I may be able to simulate this problem just by revving this. So let me rev up the engine. Watch the red channel, which is my high side fuel pressure. That should increase when I rev. Injector should cut off when I let off. So here we go. There we go. And what do you see? We see a drop in pressure on our low side. When our high side is rising, our low side is dropping. That should never ever drop on a rev. It should maintain steady. That's even worse. Look at that. That's even worse. I don't need to go for a test drive. That capture is the money shot right there. We are done. this car has a bad low side fuel pump. Now, before we condemn the pump, all we have to do is to go back to the low side and we measure our powers and our grounds to that pump. We want to make sure that the power supply is steady to the pump. If the power supply is steady to the pump, then we have a bad pump. If the power supply is not steady to the pump, then we have to interrogate that line and see why we have this problem. But right now, we are done. Here's a fuel pump, and it's with the sensor assembly. Power and ground is white black, that's the ground, and blue black, that's the power. It comes from a fuel pump relay. So I'm going to go back here and probe these two wires on independent channels. It's never a wise idea to probe on one channel, simply because if you have a problem on the power or on the ground side, you're going to hide it from yourself on the power side. So we're going to remove the injector channel and the coil channel and connect the power on channel 3 and the ground on channel 4. Our pump is easily accessible from the back seat, and that is here. And there is our pump. Now, before I probe this, just want to show you guys something. This is typical Kenyan Kawaya style of probing. What these guys do is that they take a razor blade, they cut the wire to expose it, and then they probe it. That's a pretty stupid thing to do, because this now exposes this wire to moisture and it'll corrode. If you want to probe wires like this, you need to use proper probes. I suggest using the Pomona pin probes. Those are the best that I've seen in the market, and they make a very tiny incision on the insulation, and when you're done and you remove it, it actually closes itself up. You don't even have to do much. And if it's too big, you just put a bit of liquid electrical tape, and you're done. This is poor workmanship, should never be done. And you probe these two wires, and then we take the capture of the powers and grounds at the pump. There are our pump connections. I have pump power on channel 3 and pump ground on channel 4. And these are the probes I was talking about. These are the Pomona probes. Very nice probes. You can get them from Amazon.com. Scope is set up. Start the scope. And we put on the ignition and start the car. And there are our voltages. Now let's accelerate. And stop the scope. I'm going to filter C and D. We've got good ground, we've got good power. This power is maintaining at 13 volts. But the strange thing is now we're not dropping as we were before. So I'm going to let this thing run for a few more seconds, let that pump get a bit hot, and then see what happens. So I ran the car for about 5 more minutes, and the pump is beginning to make some very weird noises. But our pressure is not dropping as much. It is a bit, but not as much. But before this, the car had been running for close to half an hour while I was testing the other, doing the other diagnosis. So there we go. We're still dropping a bit right there. So if I stop that, so we're still dropping pressure here as we're raising here. So we are done. We don't have a power issue here. We don't have a ground issue on the pump. This is just a bad pump. Now I want you to hear what kind of noises this pump is making. You can hear that. There's a ticking noise, and it seems to be corresponding with the waves that we are seeing on the pressure side of this pump. So this pump has a mechanical problem inside. We are done. This car needs a new low side pump, and we need to fix the front side where we have those air leaks. Once we're done with that, this car should be back on the road, no problem. That's it. Another one for the books, and we are done. See you next time.